September 15th, 1982, 13:45 Eastern Daylight Time. A Lockheed L-1011-1 TriStar sits at Gate B-12, Miami International Airport. The aircraft registration, N31032. Eastern Airlines Flight 855 to New York, Kennedy. Captain Thomas Harrison walks beneath the wing, examining the two Rolls-Royce RB211-22B turbofan engines. Each produces 42,000 pounds of thrust. Each represents advanced, high-bypass turbofan technology. The third engine sits in the tail. Unlike the DC-10's curved S-duct, the L-1011's center engine mounts straight through the vertical stabilizer. Air flows directly from intake to engine. No pressure losses, cleaner aerodynamics, more complex manufacturing. First Officer Michael Chen checks the main landing gear. Flight Engineer Robert Martinez monitors hydraulic systems and fuel quantity. The L-1011 operates with a three-person crew, standard for wide-body aircraft in 1982. The design competition, Lockheed developed the L-1011 in response to the same airline requirements that spawned the DC-10. Airlines wanted wide-body capacity for domestic routes. Aircraft smaller than the 747, but larger than narrow-body jets. Both Lockheed and McDonnell Douglas proposed trijets. 3 engines provided adequate thrust, operational flexibility, better economics than 4-engine configurations. But Lockheed approached the design differently. Where McDonnell Douglas prioritized fast development and early market entry, Lockheed emphasized technical sophistication. More advanced systems, more automation, more redundancy. The center engine installation exemplified this philosophy. The straight-through mounting required cutting the vertical stabilizer. Complex structure, difficult manufacturing, but aerodynamically superior. Lockheed chose the Rolls-Royce RB211, a revolutionary 3-spool turbofan. Better fuel efficiency than competing engines, more advanced design. But the RB211's development encountered severe problems. In February 1971, Rolls-Royce declared bankruptcy. The British government nationalized the company to preserve the program. The crisis delayed L-1011 deliveries. Eastern Airlines received its first TriStar in April 1972, nearly 2 years after the DC-10 entered service. By the time deliveries began, the DC-10 had captured significant market share. Lockheed never recovered. Cockpit systems. Inside the cockpit, Harrison occupies the left seat. Chen takes the right. Martinez sits at the flight engineer's station. The instrument panel displays analog gauges. But the L-1011's systems represent advancement beyond previous generation aircraft. The autopilot is sophisticated, capable of fully automatic approach and landing in 0-0 conditions. The aircraft can land itself with no visibility. This autoland capability requires redundant systems. 3 independent autopilot channels, triple redundancy in flight control computers, 4 hydraulic systems instead of the DC-10's 3. The flight director displays command information. The pilots can fly manually following director commands or engage the autopilot to execute automatically. Navigation uses triple inertial navigation systems, dual VOR receivers, dual DME. The systems integrate through the flight management panel, not a computerized FMS like modern aircraft, but sophisticated analog coordination. Martinez's engineer panel monitors all systems. 3 columns of engine instruments, fuel quantity for 7 tanks, 4 hydraulic pressure gauges, electrical generation from 3 engine-driven generators plus APU. The RB211 engine. The Rolls-Royce RB211 represents a technological leap. Three-spool configuration, three concentric shafts rotating at different speeds. This allows optimal operating speeds for fan, intermediate compressor, and high-pressure compressor. Competing engines use two-spool designs. The RB211's three-spool architecture provides better fuel efficiency and wider operating range. The high bypass ratio means most air flows around the engine core rather than through it. Efficient thrust production, quieter operation. Engine start and departure. Martinez initiates start sequence. The RB211 uses pneumatic starting from the APU. The three-spool turbofan begins rotating. At proper RPM, fuel flow initiates. Ignition occurs. The engine accelerates toward idle, each spool settling into optimal speed. The RB211's sound is distinctive, deeper than earlier turbofans, smoother. All three engines running. Combined thrust, 126,000 pounds. Harrison taxis toward the departure runway. The widebody handles smoothly. Excellent visibility. Responsive steering. At the runway hold point, Martinez completes the before takeoff checklist. Flaps, 22 degrees. Stabilizer trim set. Flight controls checked. Auto throttle armed. The L-1011's auto throttle represents advanced technology for 1982. The system automatically adjusts thrust during takeoff, climb, and approach. Tower clears Flight 855 for takeoff. Harrison advances throttles to the auto throttle reference position. The system engages, automatically managing power. The L-1011 accelerates. 100 knots, 140 knots. V1. Decision speed. Rotate. The nose lifts. The main gear leaves concrete at 160 knots. The TriStar climbs at 2,000 feet per minute. Gear retraction. 8 main wheels and 2 nose wheels fold into wells. The L-1011's gear system operates with hydraulic redundancy. Systems integration. The TriStar turns northbound. The auto throttle maintains climb power automatically. Flaps retract to clean configuration. The flight director displays climb guidance. The autopilot follows automatically. The aircraft climbs at optimal speed. At 37,000 feet, the autopilot levels the aircraft. The auto throttle reduces to cruise settings. Cruise speed, Mach 0.84, approximately 540 miles per hour. Fuel consumption, 13,000 pounds per hour. The L-1011's systems work through sophisticated analog integration. The autopilot receives inputs from inertial navigation, radio navigation, and air data computers. It commands flight controls through hydraulic actuators powered by 4 independent systems. The flight control system uses mechanical cables as backup. If hydraulics fail completely, the crew can control the aircraft through direct mechanical linkage. This redundancy represents the L-1011's design philosophy. Every critical system has backup. Every function has alternative power sources. The autoland system. The L-1011's autoland capability represents its most advanced feature. The system can land the aircraft with zero ceiling and zero visibility, completely automatically. Triple redundancy in every component. 3 autopilot channels vote on every control input. If one disagrees, the other 2 override it. The system uses ILS and radar altimeter inputs. The ILS provides lateral and vertical guidance. The radar altimeter measures exact height for the landing flare. During approach, the autopilot flies the glide slope and localizer. At 50 feet, the system begins the flare. At main gear contact, it commands thrust reversers and applies wheel brakes automatically. Eastern Airlines operates L-1011s into low-visibility conditions regularly. The autoland capability allows operations when other aircraft must divert, descent, and landing. 200 miles from New York, Harrison receives clearance to descend. The autopilot begins descent automatically. The auto throttle reduces power. The engines settle to near idle. The L-1011 descends at 2,000 feet per minute. At 20,000 feet, New York approach vectors flight 855 toward arrival. Flaps extend in stages. Landing gear deploys. Approach speed 145 knots. The crew elects to use autoland. Harrison arms the system. All 3 autopilot channels engage. The L-1011 intercepts the ILS. The autopilot captures the localizer, then the glide slope. The aircraft descends along the electronic pathway. Chen and Harrison monitor but do not touch controls. Martinez watches all systems. At 50 feet, the flare begins. The autopilot reduces descent rate smoothly. The nose rises slightly. The main gear contacts the runway. Gentle touchdown. Thrust reversers deploy automatically. Wheel brakes apply. The L-1011 slows smoothly. At 60 knots, Harrison takes manual control. The L-1011 served airlines for over 3 decades, from 1972 to 2014, but the aircraft never achieved commercial success. Lockheed built only 250 TriStars. McDonnell Douglas built 446 DC-10s. Boeing built over 1,000 747s. The Rolls-Royce bankruptcy delayed deliveries fatally. Airlines committed to the DC-10 while waiting for the L-1011. Lockheed lacked global service infrastructure compared to Boeing and McDonnell Douglas. International airlines hesitated to order. The L-1011 required Rolls-Royce engines exclusively. The DC-10 offered General Electric or Pratt & Whitney alternatives. Lockheed never recovered development costs. The company withdrew from commercial aviation in 1984. Technical superiority. Pilots who flew both aircraft generally preferred the TriStar. Better handling, more sophisticated systems, quieter operation, more automated. The straight-through center engine proved superior to the S-duct, better efficiency, easier maintenance, more reliable. The autoland system gave capabilities the DC-10 lacked. The quadruple hydraulic redundancy provided additional safety margin. But technical superiority doesn't guarantee commercial success. The L-1011 arrived late. It cost more. It required specific engines. These factors mattered more to airlines than technical refinement. Evening at Kennedy. Flight 855 taxis to the gate. Passengers begin deplaning. Harrison, Chen, and Martinez complete the shutdown checklist. 3 RB-211 engines wind down to silence. The flight is complete. Miami to New York in 2 hours, 48 minutes. Tomorrow, this same L-1011 will fly another route. Different crew, same sophisticated systems, same automated capabilities. The aircraft that proved technical excellence doesn't guarantee market success. That demonstrated automation possibilities before digital flight controls existed. That showed what analog technology could achieve at its peak. The trijet that represented the pinnacle of pre-digital airliner design. That flew for 4 decades despite commercial disappointment. That remains, for many pilots who flew it, the finest airliner of its generation.